Imagine it's a quiet morning in early September 1859. Farmers shoulder their tools. A telegraph operator folds his hands over a wooden desk. Children play in the street. And then, without warning, the sky above them detonates in color. Curtains of green, crimson, and violet rolling and trembling from horizon to horizon. People step outside and think dawn has come at midnight. Miners in the Rocky Mountains wake up and keep working, convinced the sun has risen. A strange electric hum runs through the air. Telegraph wires, the lifeblood of every city and newspaper, begin to spit sparks. In offices from Boston to Washington, operators are knocked back by shocks. Some desks burst into flame. Others send messages even after their batteries are disconnected, powered by something that is not human at all. It was not meteor or war. It was the sun. Welcome to Singularity Animations, where we turn history and science into stories that feel close to home. On September 1st, one of the era's quiet heroes, Richard Carrington, bent over a brass telescope and sketched a cluster of sunspots. In the same moment, a brilliant white flash erupted from the sun's surface, a flare. Independently, another observer, Richard Hodgson, recorded the same strange burst. What they saw was the first documented glimpse of a white light solar flare. Less than a day later, a cloud of magnetic storm and charged particles slammed into Earth in roughly 17 hours, an almost unheard of speed for something that usually takes days to travel that distance. The result was global. Auroras that usually live near the poles spilled into temperate skies. People in places that never see northern lights, towns along the Gulf Coast, islands in the Caribbean, watched the heavens burn with unfamiliar color. Compasses wavered. Telegraph systems, long copper vines stretching like a nervous system across continents, began carrying currents they were never built for. Operators reported being able to send messages with their batteries removed. Others saw wires heat, insulation melt, and fires start. A technology of the 19th century, the telegraph, had been overwhelmed and, in some cases, set aflame by a star 93 million miles away. Those everyday details, sparks on desks, a miner waking at 1 a.m, a telegraph operator startled by an electric shock, are the human traces of a cosmic event. They are small scenes, but they invite a dangerous question. What if the sun did this tomorrow? Think about your morning routine. Your coffee machine hums to life. You check the weather on your phone. Your child's tablet blinks with cartoons. The traffic lights keep the intersection moving. Your refrigerator keeps last night's groceries cold. Behind all of that ordinary reliability are transformers and control systems, satellites and phone towers, pump stations and routers, a vast interdependent network that assumes electricity will be steady, that satellites will whisper location and time, that the grid will swallow surges and keep humming. Now imagine the sun sends what it sent in 1859, but to a world that has replaced paper with silicon. The radiation and geomagnetic storm induced massive currents in long conductors. High-voltage transformers, the giant, expensive hearts of the power grid, would absorb the brunt. If several of those transformers fail at once, they are not like a burnt-out toaster you replace in an afternoon. Many are custom-built, heavy, and hard to move. Replacement parts could take months, in some cases, years. Without power, water treatment plants and fuel pumps falter. Refrigeration stops. Hospitals switch to generators that will last only so long before fuel runs out. Communication networks falter as satellites and ground stations are disrupted. Airplanes navigate without GPS. Shipping and banking, both tightly choreographed by time and signaling, stumble. A lesser-known but crucial fact, not all harmful effects come from direct hits. Some are cumulative. Satellites exposed to increased solar particle flux can suffer slow degradation of electronics. Solar storms can erase the carefully calibrated timing that underpins finance and telecommunications, and induced currents can begin to corrode the very metal bones of our infrastructure long after the aurora has faded. In other words, the immediate flash and the headlines are only the start. The consequences ripple forward. We were closer than most people realize. In July 2012, a massive coronal mass ejection, the kind of explosion that caused the Carrington Event, erupted from the sun and raced into space on almost the same trajectory Earth would have been on. But the timing was cruelly lucky. Our planet wasn't there to be struck. Had that storm arrived 9 days earlier, when Earth occupied that spot, modern life would have received an impact similar to 1859. Only this time aimed at a planet dependent on electricity and satellites for everything from medicine to money. It's tempting to treat this like a Hollywood plot. Spectacular lights, epic failure, dramatic lines at gas stations, but the more frightening reality is quieter and closer to home. Imagine an elderly neighbor whose oxygen concentrator stops working when the power grid hiccups. Imagine a small town whose municipal wells fail when pumps lose power. Imagine a farmer's freezer full of meat slowly thawing over the course of days with no reliable refrigeration and no immediate supply line to replace it. These are small human catastrophes, each one ordinary, each one devastating to the people living it. There are facts about the Carrington Event that rarely make the sound bites. Telegraph operators used the storm's induced currents to continue sending messages for a while, sometimes exchanging notes about the sky and the strange powers in the wires. In some cases, sparks leaped so wildly that operators had to step back to avoid being burned. Newspapers that could print fast enough used telegraph lines to send urgent dispatches across the Atlantic, producing a surreal mix of awe and panic, humanity communicating about a star's anger while its own wiring smoked. Governments and scientists do watch the sun. Satellites circle our star. Observatories track sunspots. Agencies issue alerts when the sun awakes. But the warning window for a fast, Earth-directed coronal mass ejection can be painfully short, a matter of hours. And even then, our options are limited. You can unplug a device, you can take cars off the road, you can attempt to protect transformers, but you cannot stop charged particles from striking our magnetic shield. So, what do we do with this knowledge? The answer is not to live in fear, but to choose memory over complacency. The Carrington Event is not a ghost story from a distant century. It is a clear, recorded example of the sun's capacity to alter life on Earth. Planners and engineers use it as a benchmark, a reminder to harden systems, to diversify power sources, to keep redundant manual ways of performing essential tasks. And on the personal level, it's a reminder that the conveniences we take for granted are built on fragile seams. A battery, a solar charger, a neighborhood plan for elders, small steps can change how a family weathers a long night. At dusk on the day of the Carrington Event, people who had watched the sky bloom and the wires hiss returned to their lives, some with tales of color and shock, some with burned paper and stories that sounded like myth. The sun went back to being a steady presence overhead until the next time it chose to roar. The truth is simple and terrible. The star that makes life possible also has the power to remind us of its force. When the sky lights up, it's not a show we are entitled to watch without consequence. It is a cosmic reminder that our quiet, electric world sits within a solar system that is active and sometimes violent. So, when you step outside tonight and look up, remember the men and women who watched the sky light up in 1859, and remember that the same star still spins above us, indifferent to our schedules. We can listen, we can prepare, we can build systems that bend but do not break, and we can tell the story, because remembering is the first line of defense. This is the story of the day the sky went dark and then burned bright again. A moment when the sun reached down and touched the wiring of a nation. It is history, it is science, and it is a warning. The next time the sun decides to shout, it won't ask our permission.